And today we're going to be talking, Amy's going to be sharing with us Regex Crash Course. And Amy is a senior software engineer currently working at MURAL. She loves information, human interaction, solving problems, helping people and cats, not necessarily in that order. Also, Amy would prefer to sing rather than to speak in front of a group of people, but she is here and she's going to speak in front of us or sing it like which I 100% encourage. So, thanks, Amy, for being here with us today and talking to us about Regex and giving us a crash course.
Yeah. Not singing this time. Tried to turn it into a parody song. Didn't have enough time. I wouldn't get it through in 10 minutes. So my name's Amy, and I'm going to give you a crash course in Regex. So good at slides. All right. So what is a regular expression? A regular expression is a way to describe a pattern to match text. It's usually used for find replace or data validation for input that is strings. So the syntax is generally /pattern/flags. And I'm going to specifically be talking about JavaScript flavored regex. There are different flavors, so the syntax is slightly different across different kinds of regex. So flags are an optional parameter that modifies the behavior of the search. So generally in the wild, you will see the global flag, which means that you will match any occurrence in a string rather than stopping at the first one. The multi-line flag, which allows new line characters to be matched as though they are the beginning and end of strings. The Unicode flag, which allows for better Unicode feature support, and the ignore case flag, which means that you can write a regular expression and only have one case in the regular expression and it matches both. So like if you include capital A through Z, it will also match lowercase a through Z. All right. It's important when you're going to be writing a regular expression or thinking about solving a problem with a regular expression to really understand the problem you're trying to solve. You have to know the things that you want to match, but you also have to know the things that you don't want to match. And let's go through a simple example to show how important it is to really understand what you're trying to do. So this is a regular expression, meow, with a global flag. This is trying to match every instance of meow in a string, right? And it does succeed in that. You are going to match meow. Unfortunately, the word homeowner also includes the word meow as a substring. So when you have a regex that matches meow globally, you are matching meow, but you are also matching homeowner, which is not the intended target. So the way you solve for that is to make use of regex assertions. So the caret at the beginning of a pattern means that you're matching the start of the string, or in the case of a multi-line flag, the start of a line, and the $sign at the end of the pattern means you're matching the end of the string or the end of the line. So this means that every instance of meow, you are ensuring that you are only matching meow. This will work globally. It won't work. This is a poor example, I just realized, because unless you're having meow in as the only word in a line, it's not going to be super helpful. But it does solve for the no longer matching homeowner. So assertions are conditions that have to be met in order for a match to be possible, and they don't consume characters, unlike other parts of a pattern. So we've already covered the start of string and end of string assertions. Now there's word boundaries. So a word boundary is denoted by the pattern /b, and it's going to match before the first character in a string if that first character is a word character, after the last character in a string if the last character is a word character, or between two characters in a string where one word is a word character and one character is a word character and one is not a word character. We also have the inverse of this pattern. So in general, the The pattern for regex is lowercase is inclusion, uppercase is exclusion. So a capital B is non-word boundaries. Then you have look-aheads, which are awesome. It means that you have a pattern, and after that you have a look-ahead. It can be a positive look-ahead or a negative look-ahead, but in the case of a positive look-ahead, it's saying you will only match this pattern if after that pattern the contents of this look-ahead is present. In the case of a negative look-ahead, you're matching the pattern only if the next part of the pattern does not include the look-ahead. So in the case of regex is aw, negative look-ahead full, you will be matching regex is aw in regex is awesome, regex is aw in regex is awe-inspiring, but not regex is awful. Then there are look behinds. That's the same principle, but the other side of the pattern. So you're looking behind your string to see if the contents of the string includes or doesn't include. So for a positive look behind, you're saying that this part of the string has to be present in order for the second part of the string to match. In the negative look behind, this part of the string can't contain what's in the negative look behind. And then you'll match the string. So with a negative look behind dog's space and followed by rule, it will match the rule in cat's rule, it will match the rule in people watching this talk rule, but it will not match the string dog's rule. Then we have character classes. This is not an all-encompassing list of character classes. There are other character classes, some of them being my favorite Unicode property escapes. But these are the main ones you will see in the wild. Word characters, which is A through Z, uppercase and lowercase, 0 through 9, and an underscore. Non-word characters, which are everything that is not encompassed by a word character. Digit characters, which is 0 through 9. Non-digit characters, white space, which is space, tab, form feed, line feed, Unicode spaces, non-white spaces, and period is any character except line terminators, except when you have .all set. .all is a flag. .all will also match line terminators. And then you have disjunctions, and a disjunction is like an alternate. So x, in this example, x or y, it will match x or it will match y. It could be either. So we also have character sets. A character set is anything within it's like having a disjunction between different options if you have multiple options. So in this case, x or y, it's the same as having x disjunction y. But you could have multiple things in a character class to denote things that you want to match against in that for that character. You also have negated character sets. That's saying that you don't want to match any of the things included in the negated character set, but it could be anything that is not included in the negated character set, if that makes sense. So if you have a negated character set of F followed by aim, you would match game, tame, lame, but not fame. All right, question. Are these two regular expressions equivalent? We've already covered character sets and negated character sets, and we know that the capital D means non-digit, capital W means non-word, lowercase d means digit, lowercase w means word. So is the character set of non-digit, non-word equivalent to the negated character set of digit and word? The answer is no. All right. So because a character set is saying that something can match this or this, what it actually is doing is finding that something is not a digit, and that is the only thing it's not matching against, because if it's not a digit, it could be a word. So it's, imagine this, and a non-word, like because there's the overlap that a word contains digits, that's why it's matching everything except digits. Whereas if you use a negated character set of digit and word, you are matching everything that is not a digit and not a word. So this is an and this is an or. It's kind of important to know the difference. We also have quantifiers. Quantifiers are the number of times you want to match something. So you have a pattern, the pattern is followed by an asterisk. That means you want to match that character 0 or more times. And the quantifiers only apply to the character or sub-expression that you're dealing with. So you can have a capture group that we're not covering in this talk, but a capture group is can be multiple things, and in that case, the quantifier applies to that group of things. But if you see it next to a character by itself, it's not in a capture group or a non-capture group, then it's applying only to one character. So if you have X and a asterisk, it can match X, it could match XXX, it could match XX, etc. X plus means it has to match one or more times, so you can't have no X, whereas like if you have X asterisk, that's an option. It could also be it cannot exist. So it doesn't have to be in the expression in the string. Whereas when you have X plus, it has to be in the string at least once. Could be more. X question mark would be 0 or 1 time. So at most 1, at least 0. If you have the curly bracket followed by a number that is matching that many times, the curly bracket, a number, a comma means at least that many times, and curly bracket, number, comma, number is at least the first number and at most the last number. And that is all my slides, and I raced through that, so I'm actually done. Sorry.
Amy, there is no reason for you to be sorry. That was fantastic. We learned so much about Regex and all of this information, lots of questions and comments in the chat. So I want to say, everybody who is watching right now, give Amy a round of applause because I think she did a very fantastic job. You can do it out loud in your own bedroom, but she will not hear that. So if you want to throw that in the chat, that is definitely cool too.